Measure resistance. You're troubleshooting a landing light that keeps blowing fuses. Voltage is normal, the bulb looks new, and the wiring seems intact. So, what's the hidden cause? Often, it's not the power that fails, but the resistance opposing the flow of electric current in a circuit. So, what exactly is resistance, and why does it matter in diagnostics? Resistance is measured in ohms and depends on three key factors: the material of the conductor, its length, and its cross-sectional area. Longer wires and smaller diameters increase resistance. Corrosion, loose connections, or heat damage can also raise resistance unexpectedly. To understand resistance in context, consider Ohm's law, expressed as voltage equals the product of current and resistance. Now let's apply Ohm's law to see what happens when voltage or resistance changes in a circuit. In a constant resistance circuit, increasing voltage increases current proportionally. But if resistance changes, for instance from a corroded terminal, the current flow will shift even if the voltage stays constant. That's why resistance measurement is a critical diagnostic step. To measure resistance, we use an ohm meter, a function found on most multimeters. Always power off the circuit first. Applying resistance testing to a live circuit can damage the meter or produce inaccurate results. Here's how we proceed while measuring the resistance using a multimeter. Set the meter to the ohm setting. Zero the meter by touching the probes together and confirming a zero reading. Adjust if necessary. Disconnect the component from the circuit to isolate it. Place the probes at either end of the resistor or conductor. Read the resistance value displayed. This tells you how much the component resists current flow. Now let's interpret what the meter is telling you. If you test a 100 ohm resistor and the meter shows 0 ohms, that's likely a short circuit. If it shows infinite resistance or OL, it may be open or burned out. Even after the reading, it's critical to follow these safety practices every time you test for resistance. Always make sure the circuit is powered off. Measuring resistance on a live circuit can damage your meter or give false readings. Never place the meter across energized connections. This could create a short and pose a hazard. Use the correct meter range and leads for the component you're testing. Mismatched settings can skew your readings or overload the device. And finally, document any abnormal resistance values. This helps track trends and supports accurate maintenance records. Measuring resistance exposes weak points, predicts failures, and ensures systems operate within safe limits. Mastering resistance testing is essential for safe and effective aircraft maintenance.